There we go. All right. Today, what I'm going to do is pass around these items and take a look at them and talk amongst yourselves what you think they are. And they come out of two different devices, but they serve the same purpose. And if you know what they are, that's cool. If you don't know what they are, that's cool too. That's the point of this exercise, okay? So just kind of pass them around, take a look. And that's something that won't come through on the video or the recording, but that's okay. This is just an example of information that I kind of thought and was expecting you to know. But the reality is, it's not your fault you didn't learn it. And what I'm using this as an example, because this is exactly the case I'm bringing to the classroom, is that some of the things we're talking about are actually those things. You may never need to know what they are, where they are, how they work, or what they're for. But the fact is, we all stand on the shoulders of giants. The knowledge base that we have has been built over several decades, years and beyond that, if you really want to get serious about it. So we are learning some of the things that admittedly go back in time, but they're still relevant, okay? If you are a true front-end web dev, a lot of this class may never apply to you. But if you do database programming, or if you do DevOps, or if you go into networking, a lot of this class will be directly related to what you need to do, okay? So as those are going around, have some fun with those. Take a look at them. And does anybody know what they are? A couple of hands go up. Okay. All right. Yeah, for breaking windows. Yeah. Yeah. And I will tell you this, one of them comes out of a motorcycle, the skinnier one. And the other one comes out of a car, an old V8 318 from the 70s, to be exact. I can't believe I found those things. I had a box of old spark plugs. They are called spark plugs. And your car will not run without them unless it's a Tesla, okay? If it's a hybrid and it has a motor and it takes gas, it has one of those things. Does anybody know where they go in the engine? There you go. That's part of it. The spark plug is part of the electrical system in a car. And there's this thing called a distributor that actually distributes the spark to the spark plug that makes a little spark that ignites the gas on the power stroke in your 4-stroke car, okay? Or 2-stroke if it's a lawnmower weed eater or something. But the spark plug is needed to fire the gas to create the explosion, to get the momentum going, so your car goes down the road. The spark plugs are typically across the top of the car. If it's a V8, like this. If it's a incline 4, your 4 cylinders are mounted like this, and they're usually across the front of the engine. And there's a thing that's connected to them called a spark plug cable, that if you disconnect, you now are running a 3-cylinder car, okay? Will you save gas? Probably not. Okay, so this is assembler. It's one of the components that make the car go. So yes, I agree, some of this stuff is obscure. Well, how does it apply to me? I'm never going to need it. That may be true. But depending on the road you're going down, you may need to do it eventually. Like if your car doesn't start in the morning, what do? 1-800-AAA, right? What if you tried to figure it out? Does the car turn over? Okay, let's say the lights go on and the car goes, or like the old guy had a stand-up comedian one time said, if your car, you start in the morning, it says, please don't try to start me. Please don't try to start me. Or leave me alone. Your car needs 3 things to run: gas, air, and spark. So if you put a potato in your exhaust pipe, which I do not recommend, it's very damaging to cars today. Your car won't start because it can't get air through the system to start. And if you're out of gas, we know what happens. It won't start. And if your battery doesn't work right, it won't start. And if something's wrong in the electrical system, say the condenser, and everything's looking good, except there's no spark on the spark plug, how do you check it? You take off one of your spark plug cables, you put the screwdriver in there, and you hold it to ground, turn the engine over, and see if you see a spark. No spark, not going to start. That's kind of why we learn these low-level things in the world of assembler. And argv, argc is their components that are the building blocks to the other pieces. Like I was showing you argv, argc in the sense of that's how we get things to work in the command line. We put in a parameter, give me this, give me the result. It hands off to the command line. And where we're going with the homework, and homework 3, is that I've given you the code for argc and argv, and we seen how it works. In homework 2, we changed main.c and foo.c, right? So it would receive an integer from the user. Okay. What you're going to do in homework 3 is change that scanf. You're going to remove that and use argv, argc to get the data into your program. So you will type in whatever you want to call a computer, the program, and then a number, and it will run and it do its thing. C. Now, I am going to give you hints on this, okay? And as usual, I may or may not give you the answer because I haven't decided if I want to use this as the midterm or not. In my programming classes, I sometimes use argv, argc as a midterm because you have to learn more than just how to copy my code and make it work. This requires a couple other steps in order to make it work. Is that we know that argc stands for count, right? We've all learned that. And v is considered a vector. What can be stored in a vector? Anything. So let's say my command line has integer, string, integer, string. And I want to do something with the integer string. And I want to compare it to something. argv, you have to convert that first one into an integer. Okay. or you won't be able to compare it to anything because it's stored in as a vector, and you can't really manipulate that vector until your C program knows what it is. I give you a number, 209-575-6761. That's my phone number in my office. Is that a string or an integer? Yeah, is a string or an integer? Is the phone number a string or an integer? You could say you strip them out. Or you use let's say it's a zip code number. Zip code. Right. You need to make an assumption of what you're going to compare it to. So if I'm going to bring in zip code, do I want to do math on zip code? Probably not. But it's just, you can, but I want to do a comparison or put it in a list of other zip codes. So basically I want to treat it as text. So in my argv, I need to say something. Say my argv1. Remember these? We've got argv bracket 1. That's my first argument in my vector. 0 is the first argument, but that's the name of the program that's running. This is actually the name of the first parameter after the program is running. So if I want a number in there, which is what we'll be doing, I'm going to put the number 8 right there. But I can't compare argv to anything yet because it's a vector and C doesn't know what to do. It's just a straight vector. I have to create something. So let's call it an integer. Okay. I'm going to just call it X. And we'll just initialize it. We'll do it in 2 steps here. So I'm creating an integer X. And then I want X to become the value of argv1. So now I take what's in the vector and it will put it in and save it as an integer. This gives me the ability to check it to see what it's doing. Okay. This little piece is, this is the concept we're doing. So I want to do that, but it's not that simple. Okay. Because it's in C and C++, I have to do something else. ASCII to integer. So I actually have to convert it first before I store it. Okay. So I'm going to give you some clues on that, on what this is about. And basically, I'll give you most of the clues, and I'll want you to plug them together and make it work. Okay. Now, like everything, it's really easy once you know what you're doing. It's really easy to change spark plugs. Once you know where they are and what kind of wrench to use and take them out, righty-tighty, lefty-loosey. But if you've never done it before, where do I start? What do I need to do? What's a wrench look like? How do I open the hood? Where do I find the spark plug? And that's where we are in this class. Okay. So that's where we're going with the next next homework assignment. Okay. And I'll give you a little more about that. There is one thing I want to talk about is the computer club. If you're interested, I will send out an email to everybody with the girls' contact info. And I have to go through a training to run a club, apparently, even though I've run the club before. Something changed somewhere. So now I have to go through a 3-hour training on how to run a student-run club. Well, basically, I show up, you do your thing, and I'm there for liability reasons. But I guess I have to know what all the appropriate paperwork is. So I have to go through a training today on that. So the computer club is run by Paulo, I think her name is. But she's in some of my other classes, and she's working with some other students to get things going. And I know Gabriel is going to be helping out. And Gabriel has also got a GitHub Classroom type account. So he can actually walk you through how to use GitHub, which is a job skill, which we don't implicitly teach here. We talk about things like version control or whatever, but we don't really teach what it is. Okay. So here's an opportunity to learn a real job skill from somebody that knows it. Okay. There's just not enough time in class to do a lot of that stuff. Okay. All right. So let's review what our homework has been. I think that's right. Let's go here. I was using that for something else. Nope, that's, let's see where I am here. Yeah. Nope, that's not the one I want. Scratch that one. Oh yeah, HW1X. Nope. I guess I could use this one. Remember our main foo.c and foo.h? We modified that to bring in parameters. And when I went through and graded everything, I was very liberal because I'm more concerned that you learn it than what your performance is. This is like this. Never seen it before. Should I penalize you because you've never seen one before? In my view, the answer should be no. That's not necessarily true in other academic disciplines. Okay. All right. Oops, I called it try to. Core dump. What happened? That's actually going to be a lecture for another whole day. What basically happened is that the program was brought into memory. Computer tried to run it, and it said, ah, splats all its brains out into a file. That's what a core dump is. Okay. Basically, it broke. Yeah, it's yeah, there's a ton of stuff in there. And the problem is core dumps in Ubuntu 18 are stored in a weird place that I haven't figured out yet, which is why I can't teach it yet. Because I'm staying a couple weeks ahead of you guys. It used to stay in the directory in which the core dump happened. I just assumed that would be the way it is. Well, things change over time, and where your core dumps end up your machine has to be configured to actually capture core dumps because they can get quite large. Okay. So basically, that's going to be part of our debugging exercise, is saying what happened with our, why did it die? Okay. So if I do the same thing and put a number in there, well, it adds 8. That's what's in my foo. Okay. And then my main, and I converted my main to take a command line argument. And here's one of the problems with C. The programmer, this is also assembler, the programmer has to do everything. It died because I did not put in any checks for the count of argv. If argv is 0, then display this error. That's not in my code. Should a machine crash if I type in a command without a parameter? No. It should have some sort of a default behavior if a parameter is left out. Okay. So it works with 1, but not with 0. Seems to ignore the second one because I can put in, well, it works for 1 and more, but not 0. Okay. So we have some issues with our code here. All right. Now, this is, having a core dump to bring up in the debugger is going to be a lot of fun. Where if I can get the core dump figured out to where you folks can actually find your core dumps by user without root permissions, I'll teach it all to you. If not, we'll come up with a plan B and we'll use the machines in front of you to be able to copy the code, run it in front of you and see where your core dumps are. I'd rather not do that because then each one of these machines are technically the same, but that's not totally true because if I run a count on what's installed, students from other classes have installed other things. So they're not totally the same. They're close enough. Okay. So this is where homework 3 is going to go. So remember main, foo, and foo-h. Remember how we compiled it? What do we need? We needed 2 C files on the GCC line, right? I'm assuming you all knew this because you did the homework. And if you didn't do the homework, well, then, oh well, you're out of luck. Okay. All right. So let me take this one over here. And because in all honesty, my very first programming class that I took as a winter term in Stan State on a Cyber 80, which is a mainframe of the day, one of many, it used a programming language called BASIC. I think I got a C, but I failed miserably. I didn't understand any of it. I realized that this may be in that same category for many of you because it's so foreign from your previous exposure in Python and C++. You do this, you hit the button that compiles. If it doesn't work, you did some syntax errors, I'll go back and I'll fix it. Well, this, it works, but I have a runtime error. That means something really broke. It could bring a machine down, okay? So we want to be able to point to, how do we find this? Play detective is what we're kind of pulling back the covers on, okay? I know you can all learn this. That's not the point. It's, what can I do as an instructor to help you find things to hook this knowledge to your previous knowledge base? But we have some gaps. That's all I'm saying, okay? All right, so this is what I want to show you. I'll make it a little bigger. Okay, I can't make it bigger there. I've got to go here and then do this. All right, fine, whatever. Okay, this is C, argv, argc. And we've looked at this before. And basically what this is doing is it's taking what I put on the command line and just printing it out, okay? Not doing any comparison, okay? It's just doing its thing. And what does this do when it runs? Okay, I'll compile it and I'll show you what it does. Now, what I'll do is just run GCC. What's my default? A.out. Okay. So if I want to change the output to something else, like hello, why not? And then I can use this. That's telling me which standard of standard C should I use to compile. Okay. Now there's others, but we can use this one as C11. This standard C11 or standard C++ 17 mean something. How many have played with Lua? The programming language is in a lot of the games. You can compile that on your own computer, but you have to compile it with the switch C11. So you can actually get your own copy, compile it for your machine, and it will run way faster than the default. Knowing how to compile from source, you got to know how to do that. Okay, that's definitely going. That's one thing you're going to walk out of this class knowing how to do. Here's a GitHub account. Here's some C source code. Follow the instructions and make it work. Okay, that's kind of what will be one of the things we'll be doing. So once I've done this, I can now run it and do 1, hi, 2, hello, spell the right way this time, 3, bye. Look familiar? Okay. Your mission is to take this code in C and put it into your main.c. So suggestion number 1, copy before you modify. Okay, take out the scanf and put in your argv, argc. Now let's look at this code. Let's talk about it. I'll bring it up in VI. Yeah. I believe the default for this machine is C11. I think could be C99, which is 1999 version. There's a global parameter, but I forget what the default is. Okay, so when in doubt, tell it. Okay. Anybody, can you see that in the back or not? Not really? Okay. Let's see if I can zoom in. Okay. That better? Sort of? Okay. All right. So what we're going to need to do is, are we going to need the loop to go through all our arguments and print them? We're going to have one. Could, but we don't need a loop through one. Okay. All right. And so we are going to need those two lines for sure. The first two lines are definitely going to need them. Okay. If we want to count the number, this would be a really good place to put an if test to say if count is what? Equal to 0, display error. Or something like that. Okay. Now, you should all know the difference between a single equals and a double equals. Let's dust off the cobwebs. One is assignment, two is equality. So if I want to take the value on the right side and put it into the box on the left, I use a single. If I want to compare the value on the right side to the value on the left, I use an equal, double equal. Yeah, you can say that. Whatever works to help you remember it. Yeah, absolutely always equals. Okay. Only, like the thing in math that used to drive me crazy. One and only one. Well, doesn't one imply only one? I never got anywhere with the instructors. Okay. So we can display an error. And that might solve our problem. Maybe, maybe not. Okay. So are we going to need to let the user know about argv 0? You are running hello. No, we don't need to know that. Okay. And we probably won't need the loop. Okay. So somewhere in here, we're going to need to see what so we want to be able to say our number. Okay. There's enough hints to get you started. So get started. We haven't covered everything. Are you in the, what directory are you in? Are you in your own personal directory? Oh, you're on the Jupyter Hub. Okay. Save the file and do pwd for me. Okay, you are in the right directory with the right permissions. Type in umask for me. Enter. Okay, that's fine. Yes, we're going to have issues. This is step one in a multi-step process. Okay. So let's start working on some code and then we'll continue down the road in a minute here. Whoops, wrong one. I want to leave that up for you. I want to take this one over to the other side. Mhm. Are you putting a dot slash in front of your file? Oh, okay. All right. Yeah, the file name is kind of important. Yeah. Mm-hmm.
Trying to make it view file created. Wait, 1 second. I'm just seeing if I can use
That's where we're going. Mm-hmm.
if there's no arguments entered.
Is the program hidden? Oh, on the return zero, that just means the program left. Yeah. Return zero is a default return code that needs to be explicitly set, or you may get a random error code, which might be 99, which might mean there's some sort of error, when in fact there's not. So in C, you tell everything to the compiler, tell it, when you complete, give me a return code. Now, if we were doing this in a production C environment, we would have a try except, and then based on the errors of the previous thing, it would return a valid error code that would point to some error list that the next programmer could actually say, oh, this is what's really wrong with this function. Okay, so we're keeping things pretty stripped apart here. Okay. All right. The part we're going to need in here is if we look at our homework 2 that we completed. No, that's not it. Syntax. That's not it. Oh. Now this is the homework 2 that we did. Okay. So basically what you'll be doing in this code is you copy this code. These 2 lines will be commented out. Okay. And you will be adding your argv, argc stuff here inside of the main. And then you're going to tell it which argument you want to pass on to. You can use, actually, you can use that one. That's fine. You can use this number and pass that number or get that number from argv1. And then I'll give you a little piece of your puzzle that you're going to need to learn how to use. And I'll just write it on the board. Okay. And then what I will have given you is all the jigsaw pieces for you to assemble it. Okay. All right. The part you're going to need is this ASCII to integer. What is it? Where is it? How do you use it? This will be what you'll be doing in industry, is that somebody's going to hand you a library and then say use it. So you're going to have to do reverse engineering on that library to figure out how to use that library. This is practice in that step. The difference is I'm giving you the answer that I know works. You just have to figure out how to make it work. Okay. So let me rewrite that so it's a little neater on the screen here. So you're looking for standard C, and it's called ASCII to integer, and it's spelled ATOI. So you can look that up in the documents or whatever. So go ahead and pass the sign-in sheet around. All right. So I've given you some pieces to work with. Here's some pieces. There's another piece. And you're going to do the Lego block thing to make it work. Okay. Please struggle with this. Please work on it. Mm-hmm. Mm-hmm. That, you know, you don't need a case statement. You can just do an if. Use an if statement to check against the number of arguments. Yeah, and then if the arguments are not right, if it's 0 or greater than 2, you put that in one line, print an error code. Please use the following. Okay, because there's standard message that when you have an error from the command line, that's called a usage error, and the usage error is fairly standard across Linux and Windows. And what it displays is, this is how you use it. Okay. And then it explains it in that printf statement right here. So this is how you use it. Usage equals command name, one variable. Okay. And then if it passes the if, then it goes to the else, which you technically don't need on a one-line if, and then has the rest of your code that passes the value from arg1 to foo. Pardon? Yeah, you can use switch if you want. You know, switch makes sense when you got like ls. How many switches are in ls? A gazillion. That's where it would make more sense. but we have just one. You could use a switch case statement if you want. Okay. And that's where we're going to stop for today. So feel free to hang out and work on this because I'll hang around and help you. And then Wednesday, we'll pick up from here and we'll try to figure out the core dump thing and make sure that we can get everybody working. Okay. So making this the midterm would be the equivalent of giving you a car that doesn't start and giving you a toolbox and say, make it run. Well, that's not really fair. All right, thank you. So when you search on Google and you search for things online, you'll find that a lot of you have great ways to search for things, but on knowledge base where you have no background, start with the big thing first, standard C. And you can put in C11 if you want, standard C11. And then ATOI, either examples, how to, or whatever. So when you use Google, if you start with the big and work your way down to the smaller element, you will usually get a search results that are a little more applicable. If you type in the question, how do I use ATI? You're going to get questions from every single language that has an ATOI in it, which may or may not be what you're looking for. So start with bigger boxes and work your way down to smaller boxes when you create your search term. Okay. Binary sort.